To my YouTube channel Shiv Academy of Mathematics. So in today's video I am going to discuss about the convergence of the beta function you know very well that that beta function is what it is integral 0 to 1 x to the power m minus 1 minus x to the power n minus 1 dx. This one is the beta function. So we have to show that this integral exists if and only if m and n both are positive. Or another statement is that discuss the convergence of the beta function, or what you have to show that this integral is convergent, or what you say this integral exists if and only if m and n both are positive. So let us start the solution, how we can show that this integral exists. So let us take this as I 0 to 1 x to the power m minus 1 minus x to the power n minus 1 dx. So here we discuss different cases. Whenever m and n both are greater than equal to 1, what happens? In these two cases, this integral I is a proper integral. Because if you look at m equal to 1, the power becomes 0 and this integral becomes 0 to 1 dx. When we simplify, its answer is 1. That is proper integral and hence convergent. And for m and n greater than 1, again these are the positive powers. So when you simplify, when you integrate it, you will get definitely the integral as a finite value, and hence it is a proper integral. That's why we can say that it is convergent. So in these two cases, whenever m and n greater than or equal to 1, this integral I is convergent. So the case remains whenever m and n both are less than 1. So what happens if m and n both are less than 1? So if m is less than 1, then this 0 is the point of infinite discontinuity due to this term, because it is having x to the power m minus 1. So when m is less than 1, this power becomes negative. That's why we can write it in the denominator, and when we put 0, it becomes point of infinite discontinuity. And when n is less than 1, then 1 is the point of infinite discontinuity. So to prove or to solve it further, what we do, we divide the integral I into two parts. One according to this 0 point of infinite discontinuity, and second one due to this point 1, which is point of infinite discontinuity. So here I have written that 0 is the point of infinite discontinuity if m is less than 1, and 1 is the point of infinite discontinuity if n is less than 1. So we discuss the case when m and n both are less than 1. So we divide the integral I into two parts, 0 to 1 by 2 and 1 by 2 to 1. This term is same, x to the power m minus 1 minus x to the power n minus 1 dx. You can also take another number other than this 1 by 2 in between 0 and 1 to solve this problem. So choice is yours. Here I have taken the number 1 by 2. So discuss these two integrals one by one, what happens in this case and in this case. So let us start by this integral I1. I1 is 0 to 1 by 2 x to the power m minus 1 minus x to the power n minus 1 dx. So as I have discussed, here x equal to 0 is the point of infinite discontinuity, because this m is less than 1. This m is less than 1. So dear students, let us take this as fx. Let us take this as fx. So fx is what? X to the power m minus 1 minus x to the power n minus 1. So next step is what? We have to reduce this fx in the rational form, or we have to change this fx in the rational form. So either you take this term in the denominator or you take this term in the denominator. So this is according to the point of infinite discontinuity, because here x equal to 0 is the point of infinite discontinuity. That's why we take this term in the denominator and this term in the numerator. And according to that, because we are going to apply the comparison test, so for that test we need another function gx also. So we take this x to the power 1 minus m as gx. That's why we have taken gx is equal to 1 upon x to the power 1 minus m. So next what we do, we take limit x approaching to 0 plus fx by gx. So when we divide this fx by gx, this term cancel out. We are having only this term, 1 minus x to the power n minus 1. So this is the case. Limit x approaching to 0 plus fx by gx is equal to limit x approaching to 0 plus 1 minus x to the power n minus 1. And when we put this x equal to 0 in this value, so we are having 1 minus 0 raised to n minus 1. So it is 1, which is non-zero and finite. You know very well about the comparison test. For that, this limit value must be non-zero and finite. That's why we can say that this integral 0 to 1 by 2 gx dx and the integral I1 converge or diverge together. Or another language, you can write that these two integrals behaves alike. But if you look at this integral 0 to 1 by 2 gx dx, so value of gx is 1 upon x to the power 1 minus m, or rather you can write it as integral 0 to 1 by 2 dx upon x minus 0 raised to power 1 minus m. So we are applying this test or this result, that integral a to b dx upon x minus a to the power m is convergent. It is convergent if m less than 1. If m less than 1. So if you compare this and this, so it is a is 0. Here a is 0. That's why we are writing it as 0. So according to that test, this integral is convergent if this power is less than 1. That means to say 1 minus m is less than 1. Or what you can say that if and only if m is greater than 0. So dear students, that means to say this integral I1 is convergent at x equal to 0 if and only if 0 less than m less than 1. So this was for I1. Similarly, we can do the calculation for I2. Sorry. So we take I2 equal to 1 by 2 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx. So again we take it as fx at x equal to 1 when n is less than 1. So again we do the same calculation. Now we take this term in the denominator, that is 1 minus x to the power 1 minus n. Because now this 1 is the point of infinite discontinuity, that's why we take this term in the denominator and the power of this x to the power m minus 1 in the numerator. So now what we do, you know very well that we take this 1 upon 1 minus x to the power 1 minus n as gx, and now we apply the limit x approaching to 1 minus. These two limits we take according to the point of infinite discontinuity, because in the first case 0 was the point of infinite discontinuity, and here the point 1 is the point of infinite discontinuity. That's why we take here limit x approaching to 1 minus. So again when we divide fx and gx both, so this term cancel out and we are having only x to the power m minus 1. And when we apply the limit x approaching to 1, so we are again having value 1, which is non-zero and finite. Non-zero and finite. So again what you can say, that this integral 1 by 2 to 1 gx dx and I2 converge or diverge together. But again just we discussed the above case. So again we can write this integral a to b dx by b minus x to the power n is convergent if and only if n is less than 1. So now we apply this result. That means to say this integral is convergent at x equal to 1 if and only if this 1 minus n power is less than 1, or that is if and only if n is greater than 0. That means to say I2 is convergent at x equal to 1 if and only if 0 less than n less than 1. So dear students, I1 was convergent for 0 less than m less than 1. I2 is convergent for 0 less than n less than 1. So when we combine these two, that means to say when we talk about this I2, which is the sum of I1 and I2, this I is convergent, which is your beta function, It is convergent if and only if m and n both are greater than 0. So that's why we can say that this beta function or this integral exists, or this beta function is convergent if and only if this power m and n both are positive. So hope so, dear students, you understand the problem. And for more mathematics problems, you can subscribe to our YouTube channel, Shiv Academy of Mathematics. So thank you for watching the video. Have a nice day.